Everyone missed me? I missed you guys too. Thanks. What's up, Leo? Abby, how's it going? Oh no. Hey, Elena. You're awake, I see. Did you go back to sleep for very long after our mentor check-in, Elena? Or at all? Or did you do your art? $30 minutes. All right, pretty good. Pretty good. Still up and going then. Cool. Okay. When would we be ready to take the AFA? All right, good question. So, we okay, hold on. Let me pull up something really quick. Come on. Come on. No, not that. Okay, so for us in college algebra, we are going to talk about ellipses today. Tomorrow, I think we'll talk about hyperbolas or parabolas and hyperbolas. Okay, a little bit, not a huge amount. So the AFA does encompass a lot of things that we don't specifically talk about. So this is, we don't have a lot of these, but this is one of the few AFAs where in order to take this AFA or in order to pass this AFA, you're going to have to do some kind of studying on your own, especially regarding parabolas and hyperbolas. Okay, the circle stuff, probably okay with. Ellipse stuff, we pretty much cover most of the ellipse stuff you need. But for hyperbolas and parabolas, objectives 3 and objective 4, we're not going to talk about that a lot just because we don't need it as much, which is why it's one of the additionals. Okay. However, lucky for you guys, there's this coronavirus that has been sweeping the world. I don't know if you've heard of it. And so all of my lessons that I've taught are online now, right? Now, even though we don't talk about conics as much in here, we do talk about conics more specifically in math analysis, my math analysis class. So let me pull this up. So for example, you guys know, or hopefully should know, that all of my videos that I do are uploaded on YouTube. So for example, if you go to my YouTube channel, Abundance Does Math, and you go to playlists, you'll see there's a playlist for each of my classes. There's College Algebra 4th block, which is us. College Algebra 2nd block, my AP Calc class, and there's Math Analysis. So if you click on the Math Analysis playlist, there's a lot of crossover between college algebra and math analysis. Analysis just it's generally faster paced and goes more into some slightly different topics, especially towards the end of the semester, like right now. But you'll see, so like ellipses and ellipses 2, that's pretty similar to what we do. All right. However, you'll notice there's 2 videos for parabolas and 2 videos for hyperbolas. Okay, because we go into much more depth with parabolas and hyperbolas in math analysis. So tomorrow I'll introduce you to parabolas and probably introduce you to hyperbolas. And we'll just kind of quickly talk about them. We won't do a lot. However, if you want to pass that AFA, you'll need to know more. And so I would recommend going to the Summit playlist, and there's resources, there's a ton of practice problems at the end of each objective in the Summit playlist, just the one you guys have. And if you want to watch like what I would teach to math analysis, because for math analysis, conic sections is a PFA. It's required. You have to do it. So we talk about it more in depth. So parabolas and parabolas 2, probably more so the parabolas 2. Well, actually both. Parabolas 2, hyperbolas 2 will both help you out a lot if you're looking to take and pass that AFA. Right. Yeah, because we'll just briefly talk about those things. But these 4 videos would definitely really help you out. Also, there's a lot of practice problems in the playlist, and there's the answers to all those practice problems too in the playlist for each objective for good practice. Okay. So when would you be ready to take it? Depends. We'll talk a little more tomorrow, but then you're going to have to go beyond that to check some stuff out on your own, watch some videos, or do some practice from the stuff I've posted, either in the math analysis playlist or just on the AFA objectives, the resources. Okay? But I believe in you. You can totally do it. It's not that it's like, it is hard. There's a lot of very small, tiny things to remember and things like that. I mean, you guys could definitely do it. It's just not one of our main focuses in college algebra, because after this unit, we definitely split to very different things in the 2 classes. So, and then throughout the year, there's some crossover, like for example this, but it's not exactly the same. But, I mean, Abby, I believe in you. I'm sure you could take it 5 minutes from now and get 12 out of 10. Guaranteed. Rock star. Okay. All right. But in the meantime, let's finish up our ellipse stuff. So what we did yesterday was practice figuring out what the equations are for an ellipse, and then how we can graph that and figure out the various pieces. So let's start going through that. Center of this ellipse is 1, -4, which I get from right here and right here. Were we not supposed to have class yesterday? Yeah, I said that yesterday I was just going to take the day to catch up on all my grading and stuff, so we didn't have class yesterday. Yep. I did grade all the performance tasks. You should see a score for that. A couple people I emailed, if you had something major that you messed up that I knew you could fix, or I knew you could fix to improve your score a lot, I emailed you that. So you can check your score. If you want to try to work on that more, send me an email. Otherwise, I emailed a few people. It was pretty good. Great job to most everyone did good. Even if you messed up, it was a small error. Do we get to see what we got wrong? I'm not gonna like make marks on everybody's and send it back to you. You can ask me if you want to email me and ask me. We can talk about that, or we can set up like a Zoom meeting or something to talk about it more if you want. Just hit me up on my email, abundance@parkhill.k12.mo.us. Send an email my test corrections. Cool. Awesome. Right, cool. Yeah, I see it in here. Good stuff. Okay, from there, a squared is always the larger of the two denominators. So in this case, a squared is 64. which means that A is 8. Since A, the larger number, is beneath the x value, or beneath the x variable, then that means this is going to be a horizontal ellipse. It's larger in the x direction. It's more wide. So I'm going to go 8 to the right. I'm going to go slightly off the page here. And 8 to the left. And these are what we call the vertices. So 1, -7. Or wait, no, sorry. What am I doing? 1, -4. And then -7, -4. B squared 16. So B is 4. That means that tells me where the co-vertices are. So now I go from the center, I go up 4, down 4. Come on. Oh my gosh. I'm going to freak out. So 1, 0, and 1, -8 are then my co-vertices. Hello, I'm late because my desktop crashed as I tried to open the stream. Wow. It must be because my stream is so high quality that your computer just couldn't handle those graphics. Like, I'm putting out intense 1080p quality, the highest quality audio you've ever heard. Please accept my PFA. Jeez. Right in the middle of class like this. Come on. Jeez. Overwhelm your graphics card. That's right. That's why you need 2 graphics cards. You need to spend $1,000 on each graphics card. All right, and then to figure out the foci, we need a squared minus b squared. So 64 minus 16. All right, so c squared, 48. So that means c square root of 48 square root of 48 I can think of as square root of 16 times square root of 3, because 16 times 3 is 48. And the square root of 16 is 4. So 4 root 3. So for the foci, for a horizontal ellipse, the foci should go left and right because it should be along the major axis, so along the longer part. So left and right. So 1 plus or minus 4 root 3. And then the y value is -4 because it's staying on the same y level. It's just moving this way. So what are those actual values if we want to graph them? So I'll calculate 1 plus 4 square root 3. 7.9. All right, so about right here. 1 minus 4 root 3. -5.9. So about right here. So I have the setup for everything and just need to figure out sort of the, or not figure out, I just need to sketch out the ellipse so we can see how this would work. Oh, nope. That's the foci. Wrong point. I'm really good at this. Anyone that says I'm not is lying. Okay. Perf. Checkmate. So there's our ellipse. Okay. So we're just going to do a couple examples today of putting into standard form. So like we did with the circle of moving from general form to standard form. And this is pretty similar, except there's a couple small differences that really screw people up because we're used to using the circle style. Okay, it's the same general steps, there's just tiny differences. Okay. So first of which, or the first main similarity is we're going to start just by moving our constant term over to the right. All right, and then on the left side, I'm going to group x stuff, group y stuff together. So 4x squared minus 48x plus 9y squared plus 72y equals negative 144. So subtract 144, group x's, group y's. Amazing. From here, with the circles, what we usually did was we just complete the square. Complete the square for the x's, complete the square for the y's, right? Add b over 2 squared to both and then to both sides. But there's differences. The difference is that in front of the quadratic terms, right, in front of the x squared and in front of the y squareds, I now have specific coefficients that aren't just 1. Right? We never had these coefficients with the circles. But for the ellipses, there will be. So we need to do something a little bit different. So the first thing that we need to do for each of these coefficients is we need to factor them out. All right, for each group. All right, so I'm going to factor one thing for the x's, and I'll factor a different thing for the y's. So if I factor 4 out of those two terms with the x's, I get x squared minus 12x. Now I'm going to leave myself some space so I can complete the square. And then for the y's, I'm going to factor out that 9. So that would leave me with y squared plus 8y. Leave some space so I can complete the square. Minus 144. Completing the square, b over 2. So negative 12 over 2 is negative 6. Why can't you factor out an x? You can. So both of these terms have an x in them. So if we were just doing GCF, then yeah, we would factor those out. But all our goal is here is just to make sure that those highlighted numbers, the 4 and the 9, are factored out. Okay, but inside the parentheses, I still want there to be x squared, plus or minus something x, plus or minus something else. Okay, so you're right though. Both terms do have an x, or both of those other terms do have a y. That's just not our goal. Our goal is not to factor it as much as possible. Our goal is just move those coefficients out so we can now complete the square. All right, but that's a great question. Okay, so negative 12 over 2 is negative 6. Negative 6 squared is 36, so plus 36. And here's where things get different. I can't just write plus 36 on the right side. Because on the left, I'm not actually adding 36 because I have this 4 out here. So I have to think about what's happening here. Well, technically this 4, if I multiplied everything out, this 4 would get distributed to every piece. So actually what's happening, whenever I add 36 on the left, I'm really adding 4 times 36. So on the right side, I'm going to add not just 36, 4 times 36. Because I have to think about, I have to imagine what would happen if all that got multiplied. And on the right, or no, for the y's, sorry, 8 over 2 is 4, 4 squared is 16, so I add 16. But I'm not just adding 16. There's a 9 in front of that, so there's a 9 being distributed. So actually, I'm adding 9 times 16. Okay, so there's one of the key differences, right, that people forget. It's super common to forget after they complete the square step. Oh, I need to distribute that. Or whenever I add to the right side, I need to think about that being distributed. So it's actually the coefficient times whatever we added in. So 9 times 16, 4 times 36. Okay, so this stuff in the red parentheses, so the 4 is out front. 4 times x minus 6 squared plus 9 in the parentheses, that would factor into y plus 4 squared equals, let's do some calculation, negative 144 plus 4 times 36 plus 9 times 16. Ah, interesting. Positive 144. That's kind of fun. That won't always happen, but it does here. Neat. So it looks a lot better. On the left, so our goal is we end up with like these fractions on the left side, and then on the right side we end up with equals 1, right, in order for this to be an ellipse. So now I'm going to say, well, what do I need to do to transform the right side into 1? Well, if I have 144, one thing I could then do is divide that by 144, right? That would give me 1. And I'll do the same thing on the left side. Divide by 144. Divide by 144, just because we have to. We have to do the same thing to both sides in order to keep equations balanced or equal. So the right side turns into 1, just like we wanted. And now for the left side, it's just simplifying fractions. So 9 over 144, I think, yeah, 16. So 9 over 144 simplifies into 1 over 16. 4 over 144 simplifies into 1 over 36. So there's the standard form for the ellipse. And if we wanted, we could go through and find out all the important information we need. We could find the center, we could find the vertices, the co-vertices, the foci, we could graph it. Lots of good stuff. So main differences are factoring out the coefficient remembering when we add to the right side, we're multiplying by whatever that coefficient was. And then once we get to our last step, we have to divide everything by whatever that right side number is so that we can transform it into 1. All right, so let's do one more of these. Same deal, put the equation into standard form. Sir Bundes, how are you handling quarantine? I'm doing great. Thriving. I'm just hanging out. All my friends are here. You know, trying to get out when I can. Go run. Go drive around every now and then. Guest taught with Miss Jury. That's right. How many views is that video up to? Let's check. It's probably in the 10,000s by now, if I had to guess. Where's that link go? Let me see here. This is the command. Yeah, someone hit that command for me. Boom. Okay, let's check this. "64 views? What is this, you guys? Have you not been sharing this with all your friends and family and stuff? 64, I'm insulted. Only 2 comments? I'm pretty sure one's from a fake account. The other is from RJ. Okay. Great comment from RJ. All right, I love that. It just doesn't. 11 likes. Why do you guys hate me? I don't get it. What did I do? Well, after everything I've given to you, and now this is how you repay me? With 11 likes, 64 views, 1 comment. Tough. Very tough. But 0 dislikes. I mean, I guess if we're going to find a silver lining in this, then I guess that's it. I suppose so. That's promising. Man, I was expecting some big moves. Wait, Mr. A, did you just hear those statistics I read off? Thank you. Finally. Oh, yikes. All right, I'm so sad. I'm gonna have to go back to math. Math is what cheers me up. All right, I'll move the constant over, group the x's, group the y's. Same deal as before. In front of the quadratic terms, we have these coefficients. So I'm going to factor those out. 588 divided by 49, I know off the top of my head is 12, obviously. Leave some space to complete the square. Factor out a 9 for the y's. So y squared plus 4y. Leave some space to complete the square. The stream's being taken over by art nerds. Complete the square for both. Negative 12 over 2 squared. So add 36. And when we add that on the right side, it's not just 36. We're adding 36 times 49. Four over 2 squared. So that's 4. When we add that on the right, we're not just adding 4, we're adding 9 times 4 because of the coefficient. This factors into x minus 6 squared plus 9 y plus 2 squared equals, do some calculation, negative 1359 plus 36 times 49 plus 9 times 4, 441. And then lastly, turn that right side into 1. So let's divide by 441. Right side is 1. Now it's just simplifying the fractions. So interestingly, 9 over 441 simplifies into 1 over 49. 49 over 441 simplifies into 1 over 9. Again, just kind of a coincidence. That won't always happen like that it just turns out being the opposite denominator. So our ellipse is in standard form. We could figure out the center, we could graph, foci, vertices, covertices, etc. Are they always going to divide evenly? Yes. For the ones that will do, I'm pretty sure that they always will. Even if they didn't, so let's say, for example, let me try to come up with an example. Okay, even if say they didn't, so I divide everything by 6. Then 4 over 6 simplifies to 2/3. Oops. So I would just write it as like this. Plus 8 over 6 simplifies to 4/3. So it would just end up looking like this. But I think most all the ones that will do end up dividing evenly, just for convenience sake. They don't have to, though. It's just nice if they do. All right. So there's ellipses. So that actually decently covers ellipses. So like I mentioned at the beginning of class, those first two objectives from conic sections, AFA, you should be good on, at least based on what we've covered. Right? For circles and for ellipses, it's just graphing, put into standard form. That's pretty much it. You know, identify the foci. You can do that. It's just the next two objectives, objectives 3 and objectives 4, that tomorrow we'll briefly talk about. We'll mostly just practice putting those into general form, from general form to standard form, though. We won't focus as much on the graphing aspect because the graphing aspect is much harder for parabolas and hyperbolas. So if you want that AFA, that's fine. It'll just take a little bit extra work. I'm not saying it'll take days and days of learning. Okay, but check out those videos that I did for my math analysis class. Those will help out a lot. And check out there's a ton of practice problems in each of the objectives for conic sections with the answers at the end of them. All right, so that should help.